So Java, invented by Sun Microsystems. It is a platform-independent programming architecture. The applications, or applets, are all written in JavaScript, and they are all written in exactly the same language. The great thing about this is they don't need to be ported to other platforms. Other forms of program, if I write a program on a Microsoft and Intel CPU, and I want to run it on a Sun microsystem running Unix, I have to port it to that hardware and software platform. And that's a very expensive process, and it often doesn't translate correctly. So the porting process is always complicated. The way Java solves this problem is all applets are written in exactly the same language. It never has to be ported. What Java provides is called the Java Sandbox, or the Java Virtual Machine. So they have a different Java virtual machine for each hardware and operating system platform, and the Java applet runs inside this Java virtual machine. So the inside of the Java virtual machine is identical 100% of the time. All Java applets will run in any of the virtual machines, and as long as you install the right virtual machine on your hardware platform, it interfaces correctly with your platform and operating system. So the outside of the Java virtual machine communicates with your platform, and this allows the Java applet to be platform independent. Now, Java uses a programming code called bytecode, and this is something you'll need to know for the exam. Bytecode means you're running a Java script or Java applet. So the Java Sandbox is a virtual machine, as I described. There is a different Java Sandbox or virtual machine for each hardware and operating system combination, and as long as you install the proper Java Sandbox on your computer, then you can run 100% of all the Java applets that have ever been written. Now, this was a form of abstraction, isolation. It was a security boundary. What happened inside the Java Sandbox could only stay inside the Java Sandbox, so we were told, until somebody broke out of the Java Sandbox and infected a host machine with malware. So the sandbox, while it is an abstraction layer, it's a security boundary, it's not as absolute as we once thought it was. It's still a Java applet that has malware inside can still break out of the sandbox, the virtual machine, and infect the host computer that's running the Java virtual machine. As I said before, Java is written in what's called bytecode, and the way Java secures its Java applets is by running a bytecode verifier to try and validate the legitimacy of the code. So the bytecode verifier is Java's approach to securing their Java applets, just like Authenticode was Microsoft's implementation to validate the correctness of ActiveX controls.